Okay, so we're going to answer this question. It says, Sue, Juanita, and Kim take turns driving a car from Kim's house to Vogel State Park, which is a total distance of 85 miles. So we're going to highlight that because that sounds important. 85 miles. Okay. If Juanita drives 5 miles less than 3 times as far as Sue, so this is also important. And Kim drives twice as far as Juanita, how far does Juanita drive? So just so you know what I'm doing, I'm circling any important information inside the question, especially this, because this is what we're trying to look for and we don't want to forget that. So it also helps just to be more organized, because that way you'll be less likely to make a mistake. So that's Juanita and that's Kim. So the first thing when we have a question like this is to define our variables. So we know that Juanita drives 5 miles less than 3 times as far as Sue. So we're going to make a variable J for Juanita. And that's how far Juanita drives. So Juanita miles. We're going to make a variable for Sue, which is E. And that's going to be how far Sue drives. And then we're going to make a variable for Kim, and that's going to be how far Kim drives. Okay, and then we're going to make some equations. So we know that what Juanita drives is going to be 3 times as far as Sue. Well, it's going to be 5 miles less than 3 times as far as Sue. So this keyword over here tells us we're going to multiply 3 to the amount of Sue, which is E. So this is going to be 3E. So 3E. And then it says 5 miles less than 3E. So we're going to subtract 5. And now we have one equation. Now it can look a bit intimidating at first because we have 3 different variables. But later on, I'm going to show you how we can use substitution so that we're only dealing with 1 variable. And then it'll be much easier to solve. So we're going to make another equation for Kim because we have some information. And that's going to be equal to twice as far as Juanita. So it's going to be 2J. And we can make one more equation, which is for the total of 85 miles. It's going to be J plus K. And we don't want to forget Sue, because Sue, even though Sue doesn't have her own equation, she did also drive. So we want to make sure we include that in our equation. And that's going to be equal to 85. Now we can substitute this so that we only have E's in the equation. So we're going to get rid of J and K. And the way we're going to do that is by using this equation right here. So J is going to become 3E minus 5. And K is going to be 2J. But we substituted J for 3E minus 5. So it's going to be 2 times 3E minus 5. And then we're going to solve that. So 3E minus 5 plus 2 times 3E minus 5 plus E equals to 85. And now, just like that, we only have 1 variable. So now we're going to combine, or we're going to get rid of these parentheses. So that's going to be 3E minus 5 plus 2 times 3 is 6E, and then 2 times 5 is 10. You have to remember that whenever you have parentheses, you are going to distribute this number to the 2, to everything within the parentheses. So you distribute it to the 3E and to the 5. And then we're going to add E equals 85. The next step would be to combine like terms, which basically means if you have 2 E's, you're going to combine those. And numbers, you're also going to combine those. So we're going to combine 3E 6e, and e, which is going to come out for a total of 10e. And we're going to combine -5 and -10, which is going to be equal to -15. And that's going to be equal to 85. Now we're going to try to isolate the variable. And what that means is we're just going to try to get this e by itself. So to do that, we're going to cancel out 15 by adding it to both sides, because the opposite of subtraction is addition. So we cancel out this, and 85 plus 15 is 100 equals e. Okay? 10e. Now we divide both sides by 10 and we get e equals 10. But you have to pay attention because we're not done yet. Even though we solved for e, we still have to figure out how far does Juanita drive. And e is how far Sue drove if we look back at our key right here. So we're going to use the equation for Juanita, which is g equals 3e minus 5. And that's going to be, we're going to use substitution. So j equals 3 times 10 minus 5. And then we're going to solve that. So 3 times 10 is 30, and 30 minus 5 is 25. So j equals 25. Now you always answer a word problem with the word answer, because if you answered somebody who asked where's the nearest mall with 3, they're going to be confused. So you have to also include other things such as miles or feet, depending on the question. In this case, this variable represents how far Juanita drove in miles. So our answer, I'm going to write it up here because we don't have room, is going to be Juanita drove for 25 miles. And that is our answer. Now we're going to do the next one. So 3 stacks of $1 bills are placed on a table. We have 3 stacks, $1 bills. The second stack has 5 more dollars than the first stack. So 5 more dollars than the first stack. We're going to circle this. The third stack has 7 more than twice the dollars in the second stack. We're going to circle this. What is the total number of dollar bills in the first stack plus the third stack combined? There's a total of 158 in the 3 stacks of dollars. Okay, so that was a lot of information. First, we have to define our variables. We know that there are 3 stacks, so we're going to have 3 variables because they did not tell us what is in any of the stacks. So we'll have x for the first stack, y for the second stack, and z for the third stack. Now, we're going to start putting down the givens or the information that they provided us. We know that the second stack, so y equals, has 5 more dollars than the first stack. So it's going to be equal to x plus 5, because x is our variable for the first stack. The third stack, which is z, has 7 more than twice the dollars in the second stack. So twice the dollars in the second stack means we're going to multiply the second stack by 2. So it's going to be 2y plus 7, because z is 7 more than y, 2y. So plus 7. Now, the one that they want is what is the total number of dollar bills in the first stack and the third stack combined. There's a total of 158 in the 3 stacks of dollars. So we know that z plus y plus x is equal to 158, because that's the total in the 3 stacks. Knowing these 3 equations, we can start solving for one of the variables. So we could solve for, let's see. Now we know we're probably going to leave X and we'll substitute Y and Z. And the reason I say that is because we don't have anything equal to X. So it would be easier to just choose X to leave, and we'll substitute the other variables for something in terms of X. So if I show you what I mean, maybe it'll be more easier to understand. We know that Y equals X plus 5. So we can substitute this for X plus 5. Z is equal to 2Y plus 7. So since we know that Y is equal to X plus 5, we can do 2 times X plus 5 plus 7. And we can substitute that for Z. And now when we put that together, X plus 5 plus 7 plus X plus 5, and then plus X equals 158. We again have only one variable to deal with, so it makes our life easier. I'm going to highlight what each part means. So 2 times X plus 5 times plus 7, that was the substitution for Z. This X plus 5 is the substitution. Oh, that's a bad color. Let me use a different color. Okay, so this X plus 5 is a substitution for Y. And this X is the same X that it was, which is the first stack. Now we're going to get rid of the parentheses. And the way we do that is we distribute the 2. So 2 times X is 2X, and 2 times 5 is 10. Next, we combine like terms. The process remains the same even if the numbers are different. So 2X plus X is 4X. 10 plus 7 plus 5 is 22. Let me double check that. 22, yes. And that's going to be equal to 158. We subtract 22 from both sides to cancel it out. And we get 4X equals 136. 136 divided by 4. We divide 4 from both sides so we can cancel it out. Divided by 4. And that's going to be X equals 34. And that is not our answer because it wants the number of bills in the first stack plus the third stack combined. We only have what's in the first stack. We still need to figure out what's in this third stack. So we need to also solve for this. So we know that the first stack is 34. To find the third stack, we have to solve the second stack first because we need to know what Y is. So 34, we're going to substitute 34 for X. So Y equals 34 plus 5. Y equals 39. Now that we know what Y is, we can solve for Z, which is the third stack. So Z equals 2 times 39 plus 7. So 2 times 39 is going to be 78. So that's going to be 78 plus 7 equals Z. And that's going to be Z equals 78 plus 7 is 85. So now we know what the third and the first stack are. We can add them together, and that will be our answer. 34 plus 85. 5 plus 4 is 9. 8 plus 3 is 11. So that's going to be 119. So the total number of dollars in the first stack and third stack combined is $119. So we're going to say let's change the color. the total of the first and third stack combined is $119. And that's our answer.